I've got 3 examples that I want to walk through with you because 3 seems to be a good number. I always seem to have 3 examples that I want to look at. But anyway, so we're going to do 3 examples that hopefully kind of tie together the concepts that we've introduced so far: perimeter, circumference, and Pythagorean theorem. So we know how to find the circumference of an entire circle. Let's say that you just had like a little semicircle, something like this. I'm going to cheat and use my little lid again. But let's say that you just had half of that circle. Well, shoot, I can't find the ruler I was using yesterday. Anyway, let's say that you have half a circle, and that your task is to find the perimeter of this figure. And let's say all the information that you know is that the length of this side is, well, let's call it 10 inches or 10 centimeters, since I used inches before. So let's say that this is the information you have. So see if you can find the perimeter of this shape. So go ahead and give the video a pause and see if you can find the perimeter here. Okay, so here's my solution. So the perimeter is going to be, of course, 10 centimeters, but then plus whatever this circumference is. Now, how do I find that circumference? Well, one thing that I could do would be to find the circumference of the entire circle, right? Now you can see why I don't try to draw these freehand. But I could try to find the circumference of the entire circle and then just take half of that, right? So half of that. So so the diameter here is going to be 10 centimeters plus whatever the circumference of half of that circle is. Well, so let's just remind ourselves, right? The circumference is pi times the diameter. I don't know why I wrote a D down here. I may have said diameter. Let me write again. Perimeter is what we're looking for. The perimeter of the circle is 10 plus whatever the circumference is. The circumference is pi times diameter, so that means this half of the circumference is pi times diameter, right, divided by 2. So that would be pi times 10 divided by 2. And you can simplify, right? 10 divided by 2 is 5. So the perimeter is going to be 10 plus 5 pi. That's our exact answer, right? So it's 10 plus 5 pi centimeters. That's the perimeter of that particular shape. Let's see about how much that is. So 10 plus 5 pi is about, so again, I'll go 2 decimal places. So to 2 decimal places, this is 25.71. Okay, and that's that one. So let's do another one kind of similar to that. Let's say this time, let's say that instead of having a full circle or a half circle, let's say that we have a quarter circle. So a quarter circle. Like that. And let's say that this segment here is, oh, I don't know. Let's say that it's 3 millimeters. Okay, so go ahead and give the video a pause and see if you can work this out. It may go without saying. I mean, so as by way of a hint, if this is a quarter circle, and you were to, let me use my lid as a cheat, and you were to complete the circle going all the way around this thing, then you can see that, this is the center of the circle, which means that this segment right here, well, I won't give it away, right? But it should be the same as that segment there, right? They should be the same length because they're both going from the center of the circle to the edge of the circle. Anyway, so give the video a pause, see if you can work out that perimeter. Okay, so here's my solution. So if I know that this is a quarter of a circle, well, first of all, so like I said, this is 3 millimeters, this is 3 millimeters then. This is the radius of the circle, right? It's the radius of the circle. Because it's going from the center of the circle to the edge of the circle. And that's how you know that these two are the same, right? They're both radii. They're both the radius of the same circle, and so they must be the same length. The only length that we don't know is this length out here. So let's see if we can find it. So again, I'm going to say the perimeter here is going to be, in this case, 3 plus the circumference of that quarter circle. Well, the circumference of the quarter circle is going to be the diameter divided by, is pi times the diameter divided by 4, right? Maybe I'll even say, right, it's the circumference divided by 4. Well, so that would be, 3 plus 3 is 6. That would be pi times diameter over 4. Or, in this case, since you were given the radius, instead of the diameter, you could use 2 pi r divided by 4. You're going to get the same result either way, okay? But if I think of this as pi times diameter over 4, and I plug in 3 for the diameter, I'm going to get the wrong result, because 3 is not the diameter, 3 is the radius. If 3 is the radius, then that means the diameter is 6, right? So this should be 6 plus 6 pi over 4. I can reduce that fraction so that I get 6 plus 3 pi over 2, right? Dividing by 2. And that's our exact answer. If you wanted to combine this into a single fraction, you could get a common denominator, right? You could say, and by the way, I'm not saying you have to do this, but just for the curious of heart, right? You could combine this into a single fraction. Now call this 12 plus 3 pi over 2, right? That would be another version of the same answer. They're both good. They're both exact answers. Oh, millimeters, we should say. Right, so it's this many millimeters. But those are the exact answers. Let's see what the approximation is. So I'm going to say 6 plus 3 pi over 2 is approximately 10.71. Okay. So there we go. Let me give you one more example. So one more example, and this one will, well, maybe I don't want to give anything away. It's going to involve another quarter circle. But this time, instead of drawing in like the actual quarter circle, I'm just going to draw in the segment that goes from that point to that point. Oh, this is where a ruler would really come in handy. I wonder what my kids did. I blame it on the kids. Let's be honest, it was probably me. I'm probably the one who misplaced it. But I had, here, I found one. I'm going to say I had 2 rulers and now I don't have any. But here we go. I'm going to connect this little quarter circle with a straight line segment now. Okay. And then I'm going to draw straight lines. That meet perpendicular, hopefully. Fairly perpendicular anyway. So that should be perpendicular. And now let's say that we know that this length from here to here is, oh, what should we use? I don't know. Let's say 4 feet. Okay. Give the video a pause. See if you can work this one out. Oh, so the perimeter I'm interested in is the bold one. So none of the dotted lines are part of the perimeter that I want. I just want the stuff that's in bold. Okay. So give the video a pause. See if you can find the perimeter of that shape. It looks almost like a bow and arrow. See if you can find its perimeter. Okay, here's my solution. So I need to find this straight line, and then I also need to find the sort of quarter circle line or curve. I don't have either of those measurements, so let's see. I know that this is a right triangle. Okay. Furthermore, I know that this segment from here to here is the radius of the circle, right, of the big circle. And this is also the radius of the big circle, so that this line segment should also be 4 feet. So now I have leg and leg. I can use Pythagorean theorem to solve for hypotenuse, right? So I'm going to break this down into chunks. So this is just scratch work for now. I'm not trying to find the perimeter yet, but what I'm going to say is leg squared plus leg squared equals hypotenuse squared, right? So where this is the hypotenuse. So 16 plus 16 equals h squared. That's 32. And then I can take the square root of both sides. So h is going to be, well, technically it would be plus or minus root 32, but since we're talking about a distance, we're going to take the positive version, right? So h is square root of 32. Now, if you think way back to your algebra days, you may remember how to simplify radicals. If you don't remember how to simplify radicals, that's okay. Don't worry about it. I'm not going to require you to do that on a test or anything like that. You could leave your answer like this. I'd be perfectly happy. Okay. But for those of you who do remember how to simplify radicals, you know that 32 is 16 times 2, and the square root of 16 is 4, so that this is really the same thing as 4 root 2. Okay. So that's the length of that line right there. I'm not going to change it into a decimal just yet because I want to get an exact answer. Okay, so I'm going to get an exact answer first, and then I'll change everything into a decimal later on. That's that one. Okay, now I need to find this sort of quarter circumference. That's nothing new. We just did a problem like that, so that's not terribly difficult. Okay, we just saw one kind of like it. We know that the radius of the circle is 4, and we want the quarter circle. So we're going to say, what should I call this thing? Maybe A, I guess, for arc length. So I'm going to say A is it's the circumference divided by 4. In other words, it's 2 times the diameter, or sorry, 2 times the radius times pi. So let me rephrase that. So pi times diameter over 4. If the radius is 4, then the diameter is 8, right? So this is going to be 8 pi over 4. And we can cancel 4s and just get 2 pi. Okay, so h is 4 root 2, a is 2 pi. That means that the perimeter, right? The perimeter would be h plus a. That's 4 root 2 plus 2 pi. And that, my friends, is the exact answer. It's not a very pretty answer, but that is the exact answer. If we want an approximation now, we can plug this in to our calculators. So I have 4 times square root of 2 plus 2 pi. And that comes out to about 11.94 feet. Okay, and that's that. I'm not going to give you any more examples, but it should go without saying that we could invent some more problems kind of like this. For example, maybe I could give you the same picture, but instead of calling this side 4, maybe I call the hypotenuse 4. Now that gives you that straight line right off the bat, but it makes it, I think, a little bit more challenging to find what the circumference is, because then you kind of have to work backwards and find one of these line segments. In fact, I think I'm going to give you a homework problem kind of like that. But you have to find these line segments so that you know what the radius of the circle is. Then once you have the radius, you can find the circumference. So anyway, but we can invent all kinds of problems that kind of go like this. But that's all I'm going to show you for now as far as perimeter is concerned. The rest is up to you.